This video is going to be an example of sampling distributions for quantitative data. So we have a soft drink bottler that claims that can volume is normally distributed with a mean of 12 ounces of soda and a standard deviation of 0.16. So we have a normal situation here. And we're being asked to find the probability that a single can of soda has a volume below 11.9 ounces. So we want to know how unusual this would be. So I am just going to find the probability of that happening. So here's 12, here's 11.9, and I want to find the probability that one can of X, one can of soda, I'm letting X represent that, is less than 11.9. Wow, Miss Griggs. Okay, so all I'm going to do is run over to staple it. Why can't I speak? So I've got the mean of 12 and the standard deviation of 0.16. So I'm plotting that distribution. I want the area to the left of 11.9. So I'm going to calculate that area. It's 26.6. So there's my answer, 26.6% or 0.266, however you want to think about it. And probability-wise, that is a pretty high probability that one can of soda that I randomly go in and pick up is going to have a volume of less than 11.9. If you don't feel comfortable with saying that's a high probability, then think about the fact that 11.9 is less than one standard deviation below the mean. Not unusual at all. So I am just going to indicate here that this does not seem unusual. With a probability of 26.6%. And the fact that 11.9 ounces is less than one standard deviation below the mean. Okay? Neato. Okay, let's look at part B. Now say we take a random sample of 20 cans from those produced in the last hour, and I now want to find the sampling distribution for all samples of size 20. So in other words, I want to know what my parameters are going to be for a sample size of 20. So the sampling distribution for all samples of size 20 means I want to know the new parameters because my standard deviation will change because I have a different sample size now. All right, the first thing we need to do when we're asked to find a sampling distribution, we must find that our conditions are met for our sample size. Is it big enough? Is it small enough? Is it independent? Do we have a random sample? Well, if you'll notice here, you're told that it's a random sample. So the 20 cans were randomly sampled, so we're good there. If you've ever seen a manufacturer produce these items, it's very fast. So I'm guessing that 20 is definitely less than 10% of all their soda cans. And of course, there's no reason to believe that the 20 cans are not independent of one another. That's why we mention independence as well as less than 10%, because I want my sample to be independent of all other samples of size 20, and I want each individual can to be independent of the other cans. So that's why I talk about that. All right, this last condition. Well, remember, this is quantitative data. You are given a measure of the ounces of soda in a can. So this is a quantitative situation. That means the NP rules are off the table. You can't use those. So for this last condition, what is it going to be, Miss Griggs? Well, guess what? It's normally distributed. So your sample size, regardless of the size, is large enough to approximate normal because we are told that it is given normal. All right, so keep in mind, all of my conditions are important so that I can approximate using the normal curve, but the one that tells me that the normal curve is can be approximated, the most important one with that idea is that my sample's large enough. Because if my sample's not large enough, it won't necessarily take on a normal distribution. So that's the one that really tells me that that I can approximate normal. So since I'm taking a sample from the normal distribution, it wouldn't matter if I was using 20 cans or 13 cans or 5 cans. If it's given normal, my sampling distribution is, it's okay to approximate normal. All right, so now I need to find my mean of X bar, and it is equal to mu, which is 12, so that works just like the proportion problems do. It is equal to the given amount for the population, the average, the population parameter average. And then my standard deviation for X bar, I am going to take the standard deviation I was given on part A, and I'm going to divide it by the square root of my sample size. That is how I determine, that is how I determine my standard deviation. So my sampling distribution for all sampling sizes of 20 is this right here. Awesome. Now on part C, in this sample of 20, the sample average soda volume is found to be 11.9 ounces. Find the probability of a sample mean that is this low for a sample of 20 is this unusual. Okay, so I want you to notice the difference in the language here from part A and part C. I was finding in part A the probability a single can of soda had a volume below 11.9, and we found it to not be very unusual. Now, I want to know how likely it is that if I take a sample of 20, it will have an average soda volume to be 11.9 or less. So now we're being asked about a sample of 20, how unusual it would be that that average amount would be less than 11.9. So now I want, and keep in mind, it's for a sample of 20. So this standard deviation, much smaller than 0.16. So is 11.9 farther below the mean this time? Yes, it is. Okay, so now my notation changes because I want to know about the sample mean. That means X bar. I want the probability that X bar is less than 11.9. So now let's see what happens there. So let's go to Staplet, and I'm changing my standard deviation, of course, to the standard deviation for all sample sizes of 20. And I want the same thing to the left of 11.9. Ooh, 0.26%. Now the probability that the average of 20 cans of soda will be less than 11.9, that's only 0.26%. That's less than 1%. This is unusual. So notice the difference between a single can, any one random can I pick, not that unusual if it has less than 11.9 ounces. But if I take 20 and it averages to be that way, there's the problem. So this is unusual. With a probability of only 0.26%. So here's what you have to think about. This is where the thinking portion comes in, okay? Because if you were to actually go into this factory and do this, and you found a sample of 20 that did in fact have an average of 11.9 or lower, okay, one of two things is happening. It just happened by chance and it's just a fluke, or there's something wrong with the idea that the mean is actually 12. Because if you were to take repeated samples of 20 and find this unlikely event occurring over and over again, something's wrong. Either the machines are not calibrated correctly, and that means that they're not actually producing an average amount of 12 ounces of soda. So that's where you have to start thinking about, okay, if you were doing this in the real world, if this happens and it happens repeatedly, something's wrong.